All right, happy Wednesday ATM. This is going to be a video on the 1-4 group section. And so what I want you guys to do is to go to Google Classroom. That's what I'm displaying right here. And underneath classwork for week 3, you'll see Wednesday, watch video notes and fill in Google Slides. So I want you to click on the group day Google Slides. And here's what you will see. You'll have your text boxes that I want you to fill in, okay? What I want you to do is go ahead and pause the video, and I want you to do this first slide completely on your own. These are just prep skills questions, simple Algebra 1 problems that you should have no problem doing on your own. So please pause the video and put all of your answers here in the bottom box. I know it's a lot of questions, but do the best that you can with it, okay? All right, once you're done with the prep skills questions, we're going to move on. The title slide we're going to kind of breeze over just like we've been doing. And then numbers 1 and 2 we're also going to skip over. Those are personal opinion type questions that we don't need to spend time on right now. So I'm going to talk about the vocabulary that's listed at the top of this slide. So we start with the word interest, okay? Interest can mean a couple of different things. For if you're purchasing a car or purchasing something big and you need a loan for it, you have to pay that money back, but you also have to pay interest back. So it's kind of considered a small fee that the bank might ask you to pay that back as well. But on the other hand, if you have a savings account and you put money in that savings account, at the end of each month, the bank might give you money as sort of a thank you for keeping your money there. And so that's sort of a good interest, okay? Now, there's a couple of different kinds of interest that you can have in a bank account. Simple interest is exactly what it sounds like. It's really easy to calculate. I'll show you guys in just a moment. Compound interest is much more complicated because the balance compounds on itself every single year. So it's a little bit more complicated, and I'll show you how to do that as well. Okay, so on this particular slide, I want you to do the best that you can to fill in your answers. Maybe tab over if you have to get to each row, or if you need to add another text box, feel free to do that as well, okay? I'm gonna pull up my blank slides so that we can work through these together. And mine don't have any text boxes on them. Okay, so we have 2 different accounts that we're going to be looking at, okay? Account number 1, we're depositing $1,000 into an account, and that pays 5% simple interest on that $1,000 each year. So we're going to figure out what 5% of 1,000 is, and it's going to be the same amount of interest every single year, okay? Account number 2, you're depositing still $1,000, and you're still getting 5%, but the interest is being compounded, which means that the interest is going to change every year based on the previous year's balance. So I'll show you what I mean once we get to number 4, but let's do number 3. Number 3 is just about account number 1, and that is simple interest, okay? All right, so for account number 1, it says getting an answer is nice, but make sure you think carefully about how the account is growing and look for any patterns. So this first column here of blank table that we need to fill in, it says how much interest will you earn in the first year, second year, third year? Well, we're getting 5% off of $1,000. So I have to figure out what is 1,000 times 0.05. In other words, I'm trying to figure out what is 5% of 1,000. And we should get $50 here, okay? So that means that every single year I'm going to get the same amount of interest. Each year it's going to be $50. That's why it's called simple interest, because the amount is the exact same interest every single year. So that means that after the first year, it says how much will be in the account at the end of the first year. So we're going to take the $1,000, we're going to add in the 50, and we get 1,050, okay? But now in the second year, we add $50 again. So we have 1,100, and then we add $50 again. $1,150. Okay, so that's simple interest. As you can see, it's pretty simple. Okay, now for question 4, we're going to be looking at the compound interest, and that's a little bit more difficult to calculate. However, the first row is still exactly the same because we're still starting with $1,000 and we're getting 5% on that. Okay, so we still get $50 in the first row in that first year. And so we still have $1,050. But here's where things get different. In the second year, your interest is not $50 again. Your interest is 5% on the previous balance. So now we have to figure out what is 5% of the previous balance. Not the original amount, but the previous balance. So I'm going to figure out, I'm going to write off to the side, what is 1,050 times 0.05? That's how much interest I'm going to have. So I'm going to take 1,050 times 0.05, and that tells me that my interest amount is $52.50. Now to get my balance, I'm going to take my first year balance and I'm going to add my new interest amount. So 1,050 plus 5,250. And my new balance is $1,102.50. Okay. Now to get year 3, again, it's not going to be $52.50 for the interest. I have to figure out what is 5% of my previous balance. So I'm going to take the 1,102.5 and I'm going to multiply that by 0.05. 5% of my previous balance, and careful, here's where you actually need to round. We get $55, but always round to the nearest penny. So the decimal is 0.125, so we're going to round to 13 cents. So be careful with the rounding. Now to get the balance, I'm going to take the year 2 balance and I'm going to add in $55.13. So I get $1,157.63. Okay, so as you can see, compound interest is a lot more difficult than the simple interest. Okay, what I want you guys to do is keep these numbers handy because the next question is actually going to ask us to fill in these into another table. Okay, so let me move on to number 5. Okay. Oh, before we get to number 5, the purple box explains what simple and compound interest are. So I've pretty much already explained it, but feel free to read through it if you'd like. And then we're going to skip over the did you get it. We might have time to do that on Thursday in class. All right, so I'm going to fill in these amounts in the table. So this is account 1, this is account 2. So remember, this was from number 3, this was account 1. So we started with 1,000, then we got 1,050, then we got 1,100, then we got 1,150. Okay, so I can erase those. Now for account 2, this is from number 4, and these are my numbers from number 4. So we started with 1,000. In year 1, after year 1, we had 1,050. After year 2, we had 1,102.5. After year 3, we had 1,157.63. So I can erase these now. All right, so now we just have to find the rest of the table. This is pretty easy. You just keep adding $50. So we have 1,200 and then 1,250. Okay. Over here, I'm going to do my work off to the side. I have to find what 5% of this balance is, and then I'm going to add that to get to the next balance. So I'm going to do 1157.63 times 0.05. The interest amount, and again, you're going to have to round, so be very careful. Oops, I wrote down the wrong number. $57.88. Again, I rounded to the nearest penny. So now I'm going to take the 1157.63 and I'm going to add in $57.88. I get $1,215.51. Okay, now to get the last row here, I have to find 5% of, again, my previous balance. So I'm going to multiply by 5%, and I get $60.78. Once again, make sure you're rounding. So I'm going to take the after 4 years balance, and I'm going to add in $60.78, and we get $1,276.29. Okay, so those are all of the numbers after 5 years. Okay. Number 6, suppose you wanted to find the value of each account after 20 years. Holy cow. Why would that be a much harder calculation for account 2 than account 1? I think you've already caught on to the fact that calculating the numbers for account 2 is much more complicated, and that's because each year's balance is found from the previous year's balance. Okay, hopefully that makes sense. We'll talk about it on Thursday if it doesn't. All right, so moving on, number 7, it says this is the calculation used to find the amount after the first year in either account. Okay, so what they do here is they're starting with $1,000 plus 5% of the previous year's balance. So for the first year, both accounts look the same, right? But what they want me to do for number 7 is it says, can you think of a way to simplify the calculation so all you have to do is one multiplication? You might not see it yet, but you have to think back to something that you learned in Algebra 1 and then reviewed in Algebra 2. It's called factoring, okay? Don't worry, I'm going to do the factoring for you and we'll never have to do it again in this class. But we're going to use GCF factoring, greatest common factor. So I look at this sort of formula that they have written in number 7, and I notice, hey, they both have $1,000. So I can factor out $1,000. In other words, I can divide $1,000 out from each term. So if I take $1,000 and divide it out, I'm left with 1, and then bring down my plus sign. Now from this section here, if I take out 1,000, or in other words, if I divide by 1,000, I'm left with 0.05. Okay, now I can simplify that by adding these numbers together. So I have 1,000 times 1.05. Keep that number in mind because we will be using it for number 9. All right, I feel like number 8 we've already talked about. Why does the value of the compound interest account grow faster? Because each balance is found by taking 5% of the previous balance, as opposed to the original amount. The simple interest just always uses the original amount, but compound interest, it's always off of the previous balance. Okay, number 9, here's a way to describe the difference in growth of the two accounts. Account number 1 increases in value by $50 each year. That was pretty obvious. While account 2 has its value multiplied by, ding, 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 1.05 every year. So the value in account 1 at any time looks like $1,000 plus 50 times the number of years that have passed. So if we wanted to figure out how much money was in the account after 20 years, we would multiply 50 times 20 and then add in the original amount, $1,000. Okay? The value of account 2 at any time looks like $1,000 times 1.05 times 1.05 times another one, or where the multiplication occurs the same number of times as the number of years have passed. So if we wanted to figure out the account balance after 20 years, we would do 1.05 times itself 20 times, or in other words, to the 20th power, and then also multiply times 1,000. Okay, so those are the fill in the blanks for number 9. All right, last little section here. Number 10, I want to fill in the blanks for you guys. This is pretty important. You guys are going to have homework problems where they're going to give you a bunch of tables and they're going to ask you, is it linear or is it exponential? And I feel like these two fill in the blanks are really going to be helpful for that. In account 1, the simple interest account, the value grows by adding the same constant number, and this type of growth is called linear growth. So I want you guys to associate the words linear growth or linear with the word adding, okay? Whenever you notice a number is being added, and then you add it again, and then you add it again, and you add it again, that's always going to be linear, okay? Now account number 2, which is the compound interest account, the value grows by multiplication or multiplying by the same constant number. This type of growth is called exponential growth. So I want you guys to associate the words exponential growth with the word multiplying. So if you notice, oh, we're multiplying by 2. Oh, we're doing it again. We're multiplying by 2 again. We're multiplying by 2 again. That's going to be exponential. Okay? All right, that's it for the notes for today. Hopefully you followed along in the Google Slides because I will be going through those and giving you guys points for them. Okay? We will touch base again on Thursday. I'll ask if there's any questions from this particular lesson, and then we'll move on to the class portion as well. Okay? Have a great rest of your day, you guys, and I'll see you on Thursday. Bye.